Here is Wasim Talib. I'm going to start a new series of my lectures to discuss analytical techniques in detail. Uh, Consider we have a substance or the compound for which we want the two things. We want to determine the two things. One is the structure of it, and other is the its separation. For structural elucidation, the techniques that can be used are the spectroscopies. Spectroscopies. The spectroscopies that can be used for the structural elucidation or the structural determination are ultraviolet visible spectroscopies, visible spectroscopies, ultraviolet visible spectroscopy, IR spectroscopy. Spectroscopy, NMR spectroscopy, as well as atomic emission and atomic absorption spectroscopies. These are the spectroscopies that can be used to determine the structure of the substance. But uh, here is the another system that can be used to determine the structure of the uh, substance, which is called as XRD, X-ray diffraction system. And mostly X-ray diffraction system is used to determine the structure for the organic as well as inorganic compounds. Mostly the technique that can be used for this purpose is the XRD. IR spectroscopy is the handful technique to determine the structure of the polymers, structure of the macromolecules. Now, the separation techniques are called as chromatographies. The modern chromatographies are very important graphies. In modern chromatographies, liquid chromatography. In liquid chromatography, one is the very finest chromatography is HPLC, high performance liquid chromatography, uh, GC, GCMS, GCMS. GC stands for the gas chromatography, and GCMS stands for the gas chromatography mass spectrometry, uh, as well as MS. A number of other chromatographies that can be used to separate the substance from the sample, which are ion exchange chromatography, gel electrophoresis. That's why we write here the etc. Today we will start from the IR spectroscopy. From before the IR spectroscopy, we should know what is the what is the spectroscopy. Spectroscopy. Spectroscopy is the interaction of interaction of radiation interaction of radiation with matter. Matter may be liquid or the solid in this liquid solid in these techniques, even it may be gases. Spectroscopy, for the spectroscopy, the radiations that are used called as electromagnetic radiations. Electromagnetic spectrum are the electromagnetic radiations. It is also called as electromagnetic radiations. Uh, these are the radiations that may have the both properties of dual nature of matter, both the properties of waves as well as the matter, as well as the particles. It may act as a wave as well as particles. Electromagnetic radiations have seven regions. The seven regions are start from the cosmic region, X-ray region, ultraviolet visible region, IR region, microwave and radio wave region. Visible, the region through which we seen the different things is called as visible region, and visible spectrum. Visible spectrum also have the seven colors. Webguyer, 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 seven color. Uh, but today we will only discuss the IR region, IR spectrum. IR spectrum has also three region. One is the near IR region, other is the mid IR region, and far IR region. Near IR region is start from the visible region, and far IR region is along with the microwave region. This is the IR region. Basically, this IR region have the two properties, have dual nature of matter, have the two properties, wavelength as well as wave number. Wavelength explain the wave property of the IR radiations, and wave number explain the particle nature of the IR radiations. For the near IR region, the wavelength is start from the 25 micron to 750 nanometer, and mid IR region has the wavelength of 2.5 micron to 25 micron. But the far IR radiation region may contain 0.1 millimeter to 2.5 micron. These are the radiations which have different wavelengths, even in the IR region. If we know, if we talk about the wave number of the IR region, near IR region have the wave number of that is start from the 4,000 to 12,500 per centimeter. Mid IR is start from the 400 to 4,000 per centimeter, and far IR region has a wave number of 10 to 400 per centimeter. This is all about the IR radiation. Mostly the IR radiations that interact with the matter is in between the 400 to 4,000, 400 to 400 to 4,000 per centimeter are the mid IR radiations interact with the matter to elucidate the structure of the compound or the substance. Now, what is IR spectroscopy? Spectroscopy. IR spectroscopy is a spectroscopy that do not give us that does not give us the whole data or the information about structure of the substance, but it only give us the idea about the functional group that may be present in a compound, in a substance. Only the functional group can be elucidated through IR spectroscopy. When IR radiations interact with matter, interacts with compound or the matter, then these radiations increase or decrease the vibrations of bonds present between the atoms of that compound. Vibrations may be of two type, one is the stretching, other is the bending. Stretching and bending. What are the compounds that give the vibrations in bonds between the atoms? Those compounds which have the dipole, which have some dipole due to the electronegativity difference. Consider here is a simple molecule which consists of A and B atoms. B has a higher electronegativity, therefore it attracts the bonding electron pair towards itself more than the A atom, and therefore the A atom contain partial positive charge and B atom obtains partial negative charge. This is the polar molecule. Mostly the polar molecules have some dipole. This dipole is shown through the arrow, which start from the highly electropositive atom towards the highly electronegative atom. And those molecules which have polarity, which have some dipole, are called as IR active. And only the IR active compounds give the very vibrations of the bonds, and these vibrations are two types: stretching and the bending. And stretching may be of two type: uh, symmetrical symmetrical or the asymmetrical. In symmetrical stretching, consider here is the atom through which two atoms are attached. Two atoms are attached. Both are maybe move upward or maybe move downward on the same time. This is the symmetrical stretching. Asymmetrical stretching, let's consider here is an atom through which there are two other atoms are attached, and one of the bond is stretched downward and other is stretched upward. The one is stretched downward and other is stretched upward. This is the asymmetrical stretching. Now the bending has four modes of vibrations. One is called as scissoring. Scissoring. In this mode, here is the two atoms. Both atoms move towards each other like scissor, like this. Both the atoms move towards each other. In other is the rocking. In rocking, both the atoms which are attached with the one atom are moved in a same plane. If both are moved toward the right side, both are moved toward the left side. In same plane, atoms move in this vibration mode. Number third is the wagging. Wagging. In this mode of bending, both the atoms move out of the plane simultaneously out of the plane, or both are moved backward the plane or the front of the plane. They are moved out of the plane or inside the plane. And fourth one is the twisting. In this mode, one atom give downward the plane and other uh, give the bending out of the plane, front of the plane. It's move upward, it's move downward. If we see in the wagging, both are moved downward the plane, the both are move upward the plane. These are the vibrations moved. And how the bonds are vibrated. For this, we should consider that the bonds are spring. Bonds act as a spring, like this, and they move uh, like this, like this. They can move in different modes. Therefore, now, what is the principle of IR spectroscopy? Consider there is an atom which is attached with a spring, and this atom may contain the mass of m1. If we apply the force downward on an atom which is attached with the spring uh, downward, then this mass is stretched like this, downward as well as upward, like this. It's moved in this fashion. uh, for this movement, uh, the force is directly proportional to the displacement x. Now, if we apply a constant which is k, and it comes to the minus k into x. Here is the x is the displacement, f is the force, and k is the force constant, force constant, or the spring constant, spring constant. This spring constant is affected by the spring strength of the spring. The displacement which is given by the force when we apply downward uh, is uh, regarding the stretching, but the number of stretchings that is happened in 1 second, or the even in unit time, is calculated within a unit of frequency. For this number of vibrations is equal to 1 over 2 pi square root of k over m. Here is the mass, k is the spring constant, and mu is the frequency. Mass is m1, mass is equal to m1. If we take two atoms with different masses, m1 and m2, attached with the spring, if we apply the force uh, on these atoms having the mass m1 and m2, they vibrate they show the vibration, and for them the vibration is totally dependent upon the frequency. Frequency is equal to, for two masses, frequency will be equal to 1 over 2 pi square under root of k over mu. uh, this is the mu is the reduced mass of the atoms, and it is called as Hooke's law. According to Hooke's law, uh, we consider the bond as a spring through which the atoms move in the different modes, in different vibrations, and different vibrations are directly proportional to the frequency, and frequency is equal to 1 over 2 pi square under root of k over m1 for the mass 1, and for mass for two masses 1 over 2 1 over 2 pi square under root k over mu, and mu is the reduced mass of the two atoms. This equation gives us the number of frequencies of vibrations that has happened due to applying the force. And now we talk about the structure of components of the IR spectroscopy. The theme of the IR spectroscopy. First of all, in IR spectroscopy, here is the source of IR. Source of IR radiations. For the source of IR radiations, the different lamps are used, which are Nernst Glover, Globar, incandescent lamps, mercury arc lamps. These are used as a source of radiations. These radiations are strike with the sample. Here is the sample compartment, in which the compound or the substance for which we are going to determine the structure is here. Sample compartment. In sample compartment, there are the two cuvettes. One is for the reference sample and other for the sample. Okay. After this sample compartment, there is the monochromators. Prism are the diffracting gratings that can be used. After this, some radiations are absorbed, some IR radiations are absorbed, which may give the vibrations in the bonds of the molecules, in the bonds between the atoms of the molecules, and other are emitted, which are detected through the detectors. Detectors that are used in IR spectroscopy are given below. given on the sides. First one is the thermocouple, and other one is the thermopile, thermistor, bolometer, and pyroelectrode. These are the detectors that are used in IR spectroscopy. After this, a spectrum is generated, which is called as IR spectrum. IR spectrum is shown on the screen, which mainly between the wavelength and absorbance are the emission. In this spectrum, different peaks are formed on the different wavelengths or the different wave numbers, like this. And different modes of vibrations, like the stretching or the bending for the two same bond may be different. For example, carbon oxygen stretching or the bending may be taken on the different wavelength, different wave number. Stretching peak and the stretching and the bending peak may may come on a different wavelength. And this is all about the IR introduction. In second lecture, we will start from the source of IR radiations. First of all, in IR spectroscopy, we we should know the source of IR radiations, in which Nernst, Glover, Globar, incandescent lamp, uh, mercury arc lamps are used. We will study in details all of these. After this, we will study the sample compartment, and after that we will study the monochromators and the detectors, and IR spectrums, and what are the factors that affect the IR spectrum uh, in interpretation of IR spectrum. Thanks for watching. Allah Hafiz.